What China's Chang'e 5 mission discovered when it dug beneath the moon and returned with fresh samples was shocking. We will thoroughly examine these priceless moon samples, and we will undoubtedly collaborate with international organizations and scientists on the scientific investigation. Once believed to be scarce on the moon, water was discovered deeply embedded in microscopic impact-formed glass beads that were dispersed across large areas. These discoveries, which have the potential to transform lunar exploration and provide groundbreaking answers to our planet's ever-rising energy needs, continue to surprise scientists. Launch and landing of a historic mission. The Chang'e 5 spacecraft was launched from the Wen Chang Space Center in Hainan Province on December 1, 2020, marking a significant milestone for China. Since the middle of the 1970s, this ambitious mission was expected to rank among the most significant lunar explorations. The probe, which weighed close to 8 tons, was designed to land on the moon, gather samples of rock from below, and bring them back to Earth safely. The Chang'e 5 lander broke from its orbiter and soft-landed in an area known as Ocean and a priceless following a 23-day spaceflight. Because of its distinctive landscape, scientists have been interested in this location, which lies on the moon's far side and close to the equator. The nearby 5,250-foot-tall Mons Rumpa Formation indicates that there was once a lot of volcanic activity in the region. The globe erupted with cheers when Chang'e 5 successfully touched down. This mission could be a game-changer for space exploration because the last time lunar material was returned to Earth was in 1976. The Chinese crew collected samples believed to be roughly 1 billion years older than any retrieved by the Apollo program by drilling into the dusty surface in just 14 Earth days. Viewers around the world were astounded by the exhilarating display of contemporary technology in action when the ascent module flew back up to meet its orbiter. The return capsule landed in Mongolia, and the samples were safely returned to Earth by December 17, 2020. The entire project was a significant turning point for space research globally and a source of pride for China. In an effort to gain a better understanding of the moon's past, particularly the processes that created its interior and surface, scientists eagerly opened the lunar samples. Many researchers think that long-held beliefs about the moon being dry and desolate may be challenged by these new rock layers. The Chang'e 5 mission also demonstrated China's space program's increasing capabilities. The nation's reputation among other spacefaring countries was improved by this launch. China is in a strong position to increase our understanding of the moon thanks to its sophisticated drilling, sample return technologies, and ambitious plans for upcoming missions. For now, decades after the first lunar explorers left their mark, Chang'e 5's successful landing confirms that robotic endeavors may still make history and spark excitement around the globe. This momentous achievement serves as a lighthouse for discovery, motivating others to keep going. Distinctive landing spot. By landing in an unexpected location on the moon, China's Chang'e 5 lander created history. Stretching over the far side of the lunar equator, Astonished is a unique landing site. Although the name implies a serene sea, this region is actually a large level expanse of dark volcanic rock, rather than an ocean. The 5,250-foot-tall Mons Rumpa, which towers over the landing area like a century, adds even more significance. Because no prior mission had ever investigated Astonished up close, scientists were thrilled. So the chance to study it was huge. Before the lander came, scientists could only investigate this region via faraway spacecraft pictures or orbiters. Large lava flows, intriguing rock layers awaiting sampling, and indications of volcanic activity were all visible in those photos. The Chang'e 5 crew hopes to learn important details about the moon's geological evolution by selecting Astonished. The existence of Mons Rumpa, which is thought to have been formed by ancient volcanic eruptions, provided even more mystery. In addition to potentially concealing significant mineral resources beneath their surface, such structures may provide hints regarding the moon's cooling and creation. This placement on the moon's far side is another factor that shocked a lot of people. Sites that could be seen from Earth were the focus of most previous missions. It required sophisticated communication equipment to land on the far side because signals could not just shoot home without the assistance of relay satellites. The Chang'e 5 mission made a successful landing at Ocean and Priolara and started its historic mission in spite of these technological difficulties. In order to find signs of buried water, volcanic layers, and interesting crystals that could provide insight about Earth's nearest neighbor, the lander bored deeper than any mission had done in decades. Due of its age and uncharted geography, scientists view this area as exceptional. It is estimated that a large portion of the rock in this area is approximately 1 billion years older than the samples collected during the Apollo missions. This implies that the expedition may offer a new understanding of the moon's beginnings. Experts anticipate that learning more about Hainan Province will further our knowledge of important occurrences such as volcanic eruptions, meteorite impacts, and the processes that created the moon's crust. These findings in such an amazing region of the moon's surface have boosted China's space exploration endeavors and inspired the international scientific community, serving as yet another reminder that there are still a lot of mysteries about the moon that need to be solved. Extensive sample gathering. China's Chang'e 5 mission, which represented a breakthrough in lunar exploration, was centered on deep sample collecting. Chang'e 5 delved deeper than any mission in decades, whilst previous past flights collected only surface dust and small rocks. This daring move held the possibility of exposing unseen lunar layers thought to be far older and more diverse than the previously examined material. Researchers aim to determine whether these deep samples would support established theories or even provide fresh concepts regarding the moon's formation. The mission's lander started its eagerly awaited drilling shortly after landing in Oceanus Priolara, a huge plain on the moon's far side. Chang'e 5's instruments reached levels that had probably never seen daylight, in contrast to previous landers that concentrated only on picking up loose lunar material. These earlier layers may contain hints about meteor strikes, historical volcanic activity, and the moon's cooling over billions of years. By excavating beneath the dust, the expedition sparked curiosity that these unexplored rocks might contain minerals, water, or other surprises that few people had anticipated finding this far from Earth. It was just half the fight to get the samples. After drilling was finished, a little ascent module on the lander launched from the lunar surface. Before returning home, it rendezvoused with the orbiting spaceship and transferred its valuable cargo. Due to their limited time, roughly 14 Earth days, the Chang'e 5 team had to work quickly and effectively. There is a little window for safe operations on the moon, particularly when taking extreme radiation and temperature fluctuations into account. Researchers from all over the world delighted as the samples returned to Earth on December 17, 2020. The content originated from older, deeper layers that might contain new information on the moon's formation. For example, a lot of scientists thought that the moon was created when a planet the size of Mars collided with Earth more than 4 billion years ago, sending heated debris into orbit. If that account is accurate, the deeper rocks might have chemical signatures that connect them to Earth or exhibit traces of extreme heating. However, if they were found to be different, it might lead to a completely different perspective on our closest neighbor. The scientific community was given a priceless opportunity to examine material that had not been examined by earlier missions because of Chang'e 5's extensive sample collection. This audacious achievement demonstrated that drilling beneath the moon's surface is both feasible and extremely profitable, paving the way for larger endeavors and possibly even for people to discover the moon's most profound mysteries themselves in the future. Ancient lunar debris. Because they originate from layers thought to be roughly 1 billion years older than those recovered during the Apollo program, the lunar samples taken by China's Chang'e 5 mission have astounded scientists worldwide. They are a rare gem in the scientific community just because of this fact. Chang'e 5 was able to reach material that had been out of sight for countless centuries by drilling deeper than many previous expeditions. The moon's formation and evolution over billions of years are described by this ancient lunar material. The moon was formed, according to a long-standing idea, when a planet around the size of Mars collided with Earth, sending heated debris into orbit. The moon formed as that debris cooled. However, due to the extreme temperatures involved, many scientists believed that the majority of water and light components would have evaporated. The additional samples, however, cast doubt on this notion. They imply that the moon still contains surprisingly large amounts of mineral and water, some of which were created by repeated impacts with meteorites, comets, or asteroids that have dotted surface for billions of years. Scientists believe these hits caused the moon's surface to heat up to extremely high temperatures, which melted rock and fused it into tiny glass beads. Water molecules from other sources, such as the solar wind, eventually got stuck within. These glass beads were discovered by Chang'e 5's lander during its subterranean drilling and returned for analysis. Even though each bead only contains a very small amount of water, researchers soon discovered that the sheer number of them on the moon might create an astonishing reservoir. The other crystals discovered in these old samples are much more intriguing. According to one study, a hitherto unidentified phosphate mineral has elements that could aid in nuclear fusion. Although the potential benefits of this recently discovered mineral are still unknown, the possibilities inspire enthusiasm and hope. Compared to the nuclear fission we currently use, nuclear fusion promises to provide a lot more energy with a lot less radioactive waste. These ancient lunar rocks disclose parts of the moon's past that scientists are only now starting to decipher since they are so old and contain remnants of cosmic events. They exhibit evidence of past volcanic activity, severe collisions, and even the presence of valuable materials like helium-3. If further investigation is conducted, these deeper, older elements may provide insight into the evolution of our nearest neighbor and could even provide a solution to our planet's energy issues. Water was found in an impact glass. Scientists from all over the world were taken aback by the Chang'e 5 mission's remarkable discovery of water on the moon concealed within tiny impact glass beads. Until recently, a lot of researchers thought that because of the moon's sparse atmosphere and high formation temperatures, any water that was originally there would have vanished long ago. However, upon examining the samples returned to Earth, Chinese experts found that there was an unexpectedly high density of these tiny glass beads, each of which contained minute amounts of water. These glass beads most likely originated when asteroids, meteors, and comets crashed against the moon's surface at enormous speeds during its tumultuous past. These collisions' heat caused lunar rock to melt, forming spherical or teardrop-shaped glass particles. The quantity of these glass particles in the lunar soil increased progressively over billions of years as a result of numerous collisions. There are innumerable beads dispersed over the surface, despite the fact that each one is smaller than a millimeter and carries only very little amounts of water, roughly 2,000 parts water per million. The water content of each bead appears to be very small on its own. The impact glass beads, however, could contain a vast amount of water when viewed as a single reservoir. Each metric ton of lunar soil might produce up to 2,000 L of liquid under Earth circumstances, assuming that each bead on the moon has the same proportion of water. Because ice deposits are thought to exist in shaded craters at the pole, it means that future astronauts may not have to limit their landings there. Rather, they could heat lunar dirt, mine it practically anywhere, and then collect the water vapor that was emitted from these beads. The probable mechanism that initially made it possible for water to form is even more astounding. Scientists believe that oxygen mixed with charged hydrogen atoms that were blasted from the sun, called the solar wind, inside the lunar glass. The beads gathered water inside their structures throughout decades of bombardment by solar particles and innumerable impact events. This discovery challenges conventional wisdom on the moon's aridity and presents a fresh image of a celestial body that might have more lunar water than we previously thought. Distribution of water on the moon. It used to be believed that the moon's water supply was restricted to the chilly, dark craters close to its poles. Then an incredible discovery was made by China's Chang'e 5 expedition. There are probably tiny water-filled glass beads all across the lunar surface. These tiny glass particles were created when the moon's rock melted due to strong meteorite and asteroid strikes. These beads were dispersed far by innumerable collisions over billions of years, resulting in a startling change in our knowledge of the distribution of water on the moon. A tiny quantity of water, around 2,000 parts water per million, is contained in each bead, which is only a fraction of a millimeter in size. The enormous volume of beads discovered in the lunar soil suggests a vast overall reservoir, even though this amount appears insignificant in a single bead. According to researchers, if cooked to Earth-like temperatures, each metric ton of lunar soil may provide over 2,000 liters of water. In other words, water might be available throughout the moon's equatorial regions, not just in areas where ice deposits are trapped in polar craters that are constantly shaded. This new perspective alters the potential operations of future lunar missions. Astronauts can think about landing in equatorial or mid-latitude zones, rather than just at the poles to look for little areas of ice. They would be able to extract water vapor from the glass beads by heating the lunar dirt that had been scooped up. This vapor might be collected and then converted to liquid water. Pioneers on the moon might be able to use locally available water in this fashion for farming, drinking, and even making rocket fuel. By eliminating the need to transport massive volumes of water from Earth, the discovery that water is dispersed over a broad range of latitudes suggests more adaptable designs for lunar habitation and may also result in lower mission costs. Additionally, scientists have figured out how the water got there in the first place. Solar wind. Before becoming caught in the moon glass and interacting with the oxygen within, streams of charged hydrogen atoms from the sun most likely traveled through space. The beads were buried in the moon's soil layer by repeated collisions over billions of years. This mechanism demonstrates how the moon may retain essential resources in unexpected ways, despite having a low gravity and no significant atmosphere. Our closest cosmic neighbor may have significantly more water than previously thought, according to the Changi 5 discovery, which opens up new possibilities for those who want to visit, live, and work there. Measuring the riches of water on the moon. Data from China's Chang'e 5 mission has taken the measurement of the moon's water content to a whole new level. According to conventional wisdom, the moon's water was mostly found near the poles as ice, trapped in craters that were always protected from the sun. New research, however, presents a very different image. Samples returned by Chang'e 5 showed small glass beads with trace amounts of water that had been generated over billions of years by innumerable meteor impacts. These little beads build up to an incredible lunar water reserve when combined. According to one of the more startling estimations, every metric ton of lunar soil that has been heated to Earth, like temperatures to release the water behind the glass, may contain the equivalent of 2,000 kilograms, or around 2,000 L, of water. Even while each bead is only a millimeter in size and can only carry a very small amount of water, their extensive dispersion over the moon means that they together contribute a huge amount to the moon's water reserves. Researchers even estimate that there may be as much as 298.7 billion short tons of water trapped in impact glass overall. Considering how dry the moon was traditionally believed to be, this is an amazing figure. The fact that these beads are not limited to a certain area is another crucial insight. The moon's surface has been gradually enriched with these water-bearing particles as a result of comet, asteroid, and meteorite encounters over the course of roughly 4 billion years. Given that water is not rigidly restricted to the pole, this distribution may provide future lunar missions greater leeway in selecting a landing location. As an alternative, astronauts may excavate in mid-latitude or equatorial regions, heat the soil, and draw enough water to sustain human needs, including drinking, agricultural cultivation, and even fuel production. Our understanding of the moon's resource potential has been drastically altered by these discoveries. This new information raises the possibility that humans could establish self-sustaining settlements in different regions of the lunar surface, when before it appeared that the only way to access usable ice was to establish outposts at the poles. Lakes and rivers won't grow on the moon anytime soon due to its thin atmosphere, but the capacity to collect and hold water from lunar soil may allow for more frequent trips and extended stays. Essentially, Measuring the lunar water abundance has ushered in a new era of space travel that goes beyond mere curiosity to actual resource use, with tangible advantages for both future research and even terrestrial energy requirements. Breakthrough in the field of mineralogy. The Chang'e 5 mission from China accomplished more than just returning samples of rock and dirt from the moon. In lunar mineralogy, it also produced one of the most unexpected findings. Researchers discovered a brand new phosphate mineral among the debris recovered from the moon's deep strata. This mineral is now known as Chang'e's Y, in honor of the mission and the legendary Chinese moon goddess Chang'e. Scientists throughout the world have been amazed by this discovery. According to preliminary research, the mineral may provide hints that could assist resolve one of humanity's biggest problems, the achievement of effective nuclear fusion. Nuclear energy is traditionally produced by splitting heavy atoms, which produces radioactive waste. However, a cleaner and far more potent alternative is provided by nuclear fusion, which combines light atoms to create heavier ones. The enormous amount of energy needed to start and maintain the process has kept mankind from mastering fusion, despite scientists' decades-long pursuit of it. Remarkably, a crucial element thought to facilitate the fusion reaction is present in the recently discovered mineral from the Chang'e 5 samples. Helium-3, a rare isotope on Earth, may be extracted from the moon and used as fuel in future fusion reactors, according to long-standing theories by numerous researchers. But up until recently, the main concern was whether the moon's crust actually contained a lot of helium-3. Change of site-wide structure suggests that it may naturally be able to hold helium-3, which has generated new interest. Indeed, according to some experts, a nearly limitless supply of clean energy might be produced on Earth if helium-3 and other essential components were extracted from the moon. The possibility that countries and private enterprises will soon vie over the moon's riches has also been raised by this discovery. There may be a gold rush for lunar resources if scientists are able to verify that Chang'e Site Y and associated minerals may streamline the route to commercial fusion power. International space organizations are expected to increase their efforts to investigate and utilize the moon's barren yet resource-rich environs, particularly those with ongoing lunar programs. Rewriting the future of Earth's energy supply and expanding our knowledge of the moon's geology and history are both exciting at the moment. Chemical secrets have been preserved as the ancient layers from which this unusual material was mined have withstood impacts and harsh circumstances for billions of years. The recently discovered phosphate mineral at Chang'e Site Y is proof that the moon can still surprise us and possibly contribute to a cleaner, more sustainable future. Opportunities for clean energy. The quest for sustainable energy has entered an exciting new phase because of China's Chang'e 5 mission. The discovery of Chang'e Site Y, a novel phosphate mineral containing components thought to be crucial for nuclear fusion, was one of the mission's most unexpected outcomes. Nuclear fusion has the potential to produce significantly less radioactive waste and far more energy than existing fission techniques. This alone raises the prospect that a stable fusion reactor may one day provide Earth with clean, practically infinite electricity. The prospect of extracting helium-3 from the moon is equally intriguing. Many experts believe that the isotope helium-3 would make the perfect fusion fuel. The results spurred by Chang'e 5 suggest that the moon may have large amounts of helium-3 in its dusty layers. According to some analysts, the entire United States could be powered for a year with just 27.6 short tons of helium-3. Considering how difficult it will be for humanity to move away from fossil fuels, that is an incredible number. Although extracting valuable fuels from the moon may seem like science fiction, it is becoming more and more feasible with every new expedition and study. Many countries and businesses may rush to establish outposts on the lunar surface if future lunar missions verify that helium-3 is plentiful and affordable to extract, seizing the opportunity to address Earth's energy crisis. Researchers are simultaneously excited and wary about the moon's new perception as a potentially rich resource. Infrastructure for mining, transportation, and processing would be necessary for large-scale resource extraction, something that could be decades or even generations in the future. However, Chang'e 5's research indicates that the moon is home to more than just rocks and dust. It also holds the potential for significant advancements in the way we power our industries and homes. Long-term stays can be supported by water frozen in glass beads, and the problem of feasible clean fusion power may be resolved by recently discovered minerals and helium-3 deposits. Our perspective on space travel is altered by such clean energy opportunities. Future missions could lead to enormous scientific and technological advancements that directly improve life on Earth, rather than just planting flags. It no longer appears impossible to power our grids with fusion fuels obtained from Luna thanks to Chang'e 5. Our nearest celestial friend might hold the solution to a cleaner, more promising future for all if we keep deciphering the moon's mysteries. Consequences for the space industry and upcoming exploration. The results of the Chang'e 5 mission have created amazing prospects for future lunar exploration and a flourishing space economy. Astronauts may no longer have to focus just on the polar regions in order to access valuable ice deposits, as the moon's regolith has been found to have a plenty of water. The alternative was for missions to land almost anywhere, collect soil that was filled with tiny impact glass beads, and then heat the soil to release water. Given that water is necessary for drinking, farming, and rocket fuel production, this significantly broadens the potential for constructing lunar outposts and homes. Additionally, scientists and energy businesses are excited about Chang'e 5's discovery of a novel moon mineral that may be used in fusion technology. If this crystal works well to support nuclear fusion, particularly when helium-3 is used as fuel, humanity may be able to access a high-yield, clean energy source. Such a discovery might lower greenhouse gas emissions and lessen our need on fossil fuels. Naturally, governments and large corporations around the world are interested in that prospect. Businesses view the moon as a resource-rich frontier ready for exploration and potentially lucrative mining, in addition to being a site of scientific interest. The international space community is therefore rushing to increase missions and advance technology. China intends to return additional samples from the far side of the moon with the Chang'e 6 mission. The goal of NASA's Artemis program is to return humans to the moon, but other countries and private enterprises are also taking the initiative. In order to spark a lunar gold rush, they intend to construct infrastructure such as fuel depots, robotic mining tools, and transit networks. Private investors have poured large sums of money into space projects because of the enticing prospect of collecting rare minerals, water, and helium-3. Thanks for watching another episode. Please like and subscribe for similar content.